I think it's working. Okay. Okay, so we were talking about one-to-one functions in horizontal line test. Again, one-to-one means that for every x, there's one y, and for every y, there's one x. Okay, it works both ways. Okay, so again, I didn't point this out, but on this one, your g of x, 3 gets 4, but 2 also gets 4. So that doesn't work, right? This one isn't a one-to-one function because you only have one x for one y and one y for one x. No, because that would be, you have like the other way. Yeah, no, because it has to be one-to-one. For every x, there's only one y. For every y, there's only one x. Okay, that makes it one-to-one. And so like with this one, see, this is a function, right? But because of that horizontal line test, we can see that it crosses it twice. It passes the vertical line test, but not the horizontal. And so this is an example here where we have the same y, for the same y value, we have two different x values, don't we? So it's not one-to-one, even though it's a function. Okay, so an inverse function, okay, if we have a function f and it's one-to-one, then it has an inverse, okay? And the inverse function has a domain of what the range was for the function, because remember I told you that x and y just switch? Well, your x values in a function are your domain values, right? And your y values are your range values. So if x and y get switched, the domain and range get switched as well, okay? So, and that's what this is saying. So the domain of one is the range of the other. So looking at x cubed, for instance, f of x equals x cubed. And if we looked at the graph of that, remember that's going to look something like this. Okay. That's f of x equals x cubed. Well, that passes both the vertical and the horizontal line test. It is one-to-one. Okay. For every x, there's one y. For every y, there's one x. Okay. And so it has an inverse function. Well, if you check it out and say this is what happens with an inverse function. If you have, if we know it's an inverse, then f of f inverse is going to equal x, and f inverse of f of x is also going to equal x. Okay, so let's try that out on this one. We said f of f inverse is going to equal x, and f inverse of f of x is going to equal x if they are inverse functions. Okay, so trying that out with the x cubed and the inverse being this, let's try that out. So it would be f of x to the 1/3, right? Which means we would say that is x to the 1/3 to the third. Well, that's x, isn't it? Because 1/3 times 3 is 1. Power to power, you multiply. And then the f inverse of f of x, f inverse of x cubed, well, into the inverse for x, I would put x cubed. So it'd be x cubed to the 1/3, which is x. So if they are inverse functions, you put one into the other, both ways, either time you're going to get x. Okay. And that's what this is saying right here. So for all x in your domain of that function, okay, whether it be a or b, depending on which one is which. Okay, so finding the inverse function, you've done this before. Now you can do that in the end. You can switch your x and y at the end too, just so you know. I think it's easier to do it to begin with, so we're going to do that, but it doesn't matter. You could do it either way. So we put y in for x, or for f of x, first of all. So we're going to replace the f of x with y. Okay. And then we're going to And this is showing you that you can do it either way. You can switch X and Y first, or I can simply solve this for X first and then switch my X and Y. These two steps, 2 and 3, it doesn't matter what order you do them in. I think it's easier to do it right away so you don't forget. Because we're used to solving for Y. That's the other thing, you know? So if you switch them right away, I think people make fewer mistakes. But it really doesn't matter. You could do it either way. So, and these steps up above are telling you to solve for X first and then switch them, right? But I'm saying, I think it works best to switch them first and then solve for Y. Okay, so let's switch X and Y. So we put X where the Y is, anywhere there's a Y, put an X, anywhere there's an X, we put a Y. And then we solve that equation for Y. So if I solve this for Y, I get Y cubed equals X minus 2, right? And then I get Y is the cube root of X minus 2. And then the last step, which I didn't write down, is just to replace your Y with this notation that indicates it's the inverse of the function. Okay, so whether it's f of x or g of x or whatever, you just put that little -1. Now, again, that -1 is not a power. It's just indicating the inverse of the function. It's not f to the -1, it's f inverse of x. That's how we would read that. Okay, so let's look at this one. If I want to find the inverse of this function, okay, so going through the steps, I would replace this with y. Right? And then I will switch my x and y and solve it for y. Now to solve that for y, I'm going to have to get this out of the denominator, right? So I'm going to have to multiply both sides by that 5y plus 4. Okay, multiply through by the x, we get 5xy plus 4x equals 3y minus 2. Now remember, you're wanting to solve this for y. So you want every term that has a y in it to be on one side and everything else to be on the other side of the equation. So I'm going to move this 3y over here to the left. So I have 5xy minus 3y equals, and I'm going to move this 4x over to the other side. So I'm separating out. So I have -2 minus 4x over here. So, and the reason you do that is because you want to get it solved for y. So you want to have anything that has a y in it over here. Yeah, and that now we want to take it out. Now we want to factor out the y because the y is what we want to solve for, right? So we factor out a y. Okay, and now I can solve it for y because now I can just divide through by the 5x minus 3. And so there it's solved for y. And so that's my inverse. -2 minus 4x over 5x minus 3. Now, you could rewrite that. You could multiply top and bottom by a negative if you want the 4x first. And so this is okay too. Either way, I mean, it depends on how you moved it, which side you moved it to is what you would get. So, okay. And if you look at this one that we have a graph of here, switching the x and the y. So if my function here is this one in blue, and I switch all my x and y values, so maybe this point, whatever, maybe it's at 5, 0. Okay. Well, then I switch it, I'm at 0, 5. So it's a reflection in this line y equals x. And when you reflect things in the line y equals x, it switches your x and y values. So that's what an inverse is. When you switch the x and y values, you get an inverse function. Yeah. Reflect it. Yeah. Okay. Logarithmic functions. So logarithmic functions have logarithms, obviously. And remember that an exponential and a logarithmic are inverse functions of each other. Okay. Now we can go from logarithmic to exponential or from exponential to logarithmic, And remember the way we do this from logarithmic, where you shown that little loop-de-loop, right? Remember? I'm sure I showed you that in pre-calc. But a to the y equals x. Well, that's exactly what you have here. Or if you're going from exponential, your base is a, so that's log base a of x equals y, because the logarithm equals a power. That's what a logarithm is giving you as a power. Okay. All right. So, and again, your domain x, you can't take the log of a negative number, remember. So x has to be greater than 0. Your range, it's just real numbers. Other things to remember about logarithms, log base a of a to the x is just x, because those are inverses, right? They basically cancel each other out. Same thing here. A to log base a, well, that's saying I'm taking a to the power that I'd have to take a2 to get x. Well, I am taking it to that power, so it's x. But again, those are inverses. Logarithm and exponential are inverse, so they cancel each other out. Laws of logarithms, a reminder about these. If you have you're taking the log of two things that are multiplied, you can separate it out, use the same bases, and you add the logarithms. And remember, logarithms are exponents, right? That's really what they are. When you do a logarithm, you're finding an exponents. And so makes sense. Multiplied, we add, right? Divided, we subtract the exponents. A power to a power, we multiply them, right? So that's why we take that r out in front and multiply it by it. Okay. So those laws of logarithms, just a reminder about that. So if I want to do this one, if I want to simplify this, get it to a single logarithm, those work the other way as well, right? So if this is log base 2 of a plus log base 2 of b plus c, then it's the same as having log of a times bc, right? We multiply those two because it was added. And then, well, we're going to do this as steps. So let's move the 3 though, where the 3 is out in front. So it goes as a power here, right? So it's c cubed. And now, yes, we'll divide, right? So this is log base 2 of, I'm going to go ahead and multiply through by that. AB plus AC over c cubed. So that's as a single logarithm. Oh, I said cubed and I wrote a 2. That's c cubed, not c squared. Okay. So questions on that? Natural logarithms. So natural logarithms, remember, it's just ln. It's just log base e, and we have a shortcut way of writing it, ln, because it's the natural logarithm. It's called the natural logarithm, remember, because it's very common in nature. So that's why we call it that. But it's still just log base e. Same things apply. You know, if you take the natural log of e, that's like saying log base e of e to the x, so it's x. The natural log of e to the x is x. And the same thing if you take e to the natural log of x, well, that's x, because e and natural log, they're inverse functions. Okay. Like there's anything else I want to say about those. So, say that again. Yeah, that's all we got. I guess I didn't have any more examples, do I? Oh, well, I gave you that one, but yeah. So yeah, there you go. I didn't, and you know, I probably should have given you an example on this one. I didn't, did I? Yeah. So this one, like, you know, if you have log base 2 of 2 to the x, that's x, because those basically cancel each other out. If you have 3 to the log base 3 of x, that's x. It wouldn't matter what those a's were. If they're the same, they cancel each other out. And it's the same thing with the e. It's just not written as log base e. So sometimes we forget that it's base e, but the natural log is base e. So e to the y equals x is, you know, the exponential version. And so again, here, it's really log base e, so it's just x. C log base E of X, so it's X. Okay, there's your assignment. Yay.